Welcome to Chapter 2, Elementary Programming. So we finished the introduction for C language. Now we start to look into the programming issue using C language. And right here, I would like to introduce the data type and also the keywords and building the second, third program, and also the operator and operator precedence in this Chapter 2. That's called elementary programming. So first, let's look at the tokens in C language. So here we have the different tokens. And these tokens are actually the reserved word. So you cannot use it for variable. So these are reserved word in C language. So you cannot use it for the variable purpose. So let's look at here. Integer, character, these are similar to Java. But Boolean is called bool. And in fact, in early C language, there's no bool data type. You only have the int data type and use the, so Boolean actually, if you had a true, in fact, it's just a constant. And it actually is 1. And if you have false, that actually is 0. And in fact, when you do check-in, anything above 0 for integer will be considered as true. Only 0 is considered false. And null, this variable null or nil, both are 0 as well. Okay. In C language, actually, the constant only has the 0 and 1. Not like other language, it has the true or false, those kind of things. In early days of C language, there's only true 0 or 1. And then derived data class, data type, you have the structure, enum, array, and union. And today, we're probably not going to talk about any of these. And there's a qualifier that's constant. Constant means a final in your Java. That's not, don't allow you to change. And volatile, and then short, long. This has different definition for the integer. As I mentioned, the short integer, long integer, they have different definition in different implementation. But in standardized C, like C89 and beyond, they do have definition, share the same definition. And there is a signed, unsigned data type in C as well. So character also have signed and unsigned. And character in C language is different from Java. Character in C actually means 8 bits, 1 byte. 8 bits and 1 byte. And this character char in Java, it actually means 16-bit Unicode, unsigned. So two actually have different definition for char. Or people call it card, I don't know. For me, I just call it character. But some people do use a char, pronounce as char. And equal means a sign, and punctuation mark, semicolon, bracket, a curly brace, parenthesis. This definition are similar to Java. Memory type code, stack heap, okay? And then pointer, star, and @ sign. @ sign means address or reference. Star sign means body or the reference. And then we have the operator plus minus, star, slash, slash for division, star for multiplication, percentage taking mode, and plus for increase, minus for decrease. One single greater sign that means greater than, and then this less than, that's equal to, greater equal to, double equal sign means equals, checking, pen equals means not equal, 2 greater sign means right shift for second number of digit, 2 less than sign means left shift, okay? And these two bitwise operation. You're working on the bit level, and they are overloaded in C++ language for the string, output string, input string, actually use. For example, like C in, you have this double less sign to get a data in, but that actually in C is not like that. C, you have the double greater than sign that actually right shift, and double less than sign is left shift. Memory management, you have the memory allocation, M allocation, C allocation, C alloc, and you have a free to free the memory, size of to check the size of a certain structure, arrays, or some data type, and calling convention. And you have the preprocessor macro, punch include, punch define, punch if define, punch if not define, punch and if those things. And punch if undefined actually is more popular, usually for the starting of a module. And you have the if then else for while and printf and scanf for the input output words. So these are the language features and keywords. And then in C language tokens, you have keyword, constant, identifier, string, spatial symbol, and operators. And these actually keyword, constant, we know, identifier is for variable, string is for literal, string literal, how to define a string. In C language, we do have the double quote and single quote for a character, double quote for a string. But C string is different from Java string, and that's actually need to be taken care of. White space letters, special letter for /n, /t, those type of escape sequence. And operators, operator is plus sign, minus sign, left shift, right shift, those operators. So this chapter we pretty much on these tokens in C language and the precedence of these operators. So tokens in C, first let's talk about keywords. Keywords. And these are reserved words in C language. For example, in, for, if, else, for, while. Identifier need to start with underline or lowercase, uppercase letters. So you root underline get character, underline sign, x1, x2, x3, x underline 1, if these are okay. Oh, okay, this one need to be capital I because that will actually avoid the requirement for keywords. So that is okay. But this one 3 to 4, no, you cannot have leading 3. Short, no, because it's a keyword. Price, dollar sign is not allowed. My space name, space is not allowed for identifier name. Constant, you have constant number, constant character, and this one 1.3 e minus 5, that's a 14-point number, and that actually is scientific notation. And token in C language, we have string literal, string actually being enclosed by double quote, okay? And single quote is for character, 13 is for a number. So these are literals. Operator, you have plus, minus, star, slash for division, a percentage for taking modulo. And you have the logic operation, double bar, vertical bar. It means the or, double at sign, that means, that actually means end. Exclamation mark, that means pen means not. And white space letters, you have the new line tab, command space, those are white space letters. Okay, C keywords. For C's keyword, we have these different keywords. And keywords is different from the tokens. Keyword is something you cannot use for variables. Now, data type. Second one, we talk about data type. Okay, first, let's talk about variable declaration. You need to have a type, you need to have a name, and then in early days, you cannot use the equal sign here. You have to have a separate assignment. But nowadays, you all have the int count equals 3. You can do declaration and assignment at the same time. So this one is declaration for a variable. And by doing this, you will actually create an integer type that's actually 4 bytes, and that actually has a name of count in there. And initial value will be 0. So that's the declaration, but it doesn't actually initialize to a certain number. So that's declaration. The next one is actually the variable in initialization. You can declare, assign value, declare, assign value, declare, assign value, declare, assign value. And that actually, a variable has the content or value. And then there's a name is X. And then there's the ages. Ages means 1, 10, 24. That is a hexadecimal code for the ages. So here, a variable really means 3 things: name, value, and the ages. 3 different things. And in C language, ages is another feature for a variable, and that is not a feature in Java. But be careful about the ages and alias or reference for a variable. It actually means different things. Variable are used to store data in C language, and variable has data type. Different data of different types are stored and interpreted in different way. The basic data type in a programming language are integers and character, logic value, floating point numbers. So you have the int. So integer in C language actually has actually signed, and usually signed you don't need to write. And unsigned, right? These are modifier. And second part, you have a long, short, or default. And then you do integer, characters. Okay, these are actually the complete format for the data type. Okay, first you have a signed, and then long, and then character maybe, or signed long integer maybe, or unsigned long integer, or unsigned long character, or unsigned short character. So they are signed, unsigned, long, short, and normal, and also have the int and character. So totally you have 2 times 3 times 2. Totally you should have how many? You should have actually 4 times 3. You have 12 different integer type. You have 12 different integer type in C language in combination. And in fact, if you are using different version for C language, it actually are more complicated. They also have the actually unsigned integer 32, unsigned integer 16. Those kind of data type defined in integer module. So we will talk about that later. But for the time being, just remember the basic 16 12 type: unsigned or signed, but signed actually usually don't write it. And then you have long, you have short, and normal, and you also have an int and character. Okay, there's no byte type because character is byte type. Okay, that's the integer. And we have a character. Character actually is unsigned integer of character type. And then you have float and double. And Boolean actually is considered as an integer, as I mentioned. But you can have the bool type as well. So C integers, we have the character, show integer, integer, long integer. So that's 1 byte, 2 bytes, 4 byte, 4 byte. Actually, that's this one can be 8 byte. Okay, and then float, double, long double. Okay, long double. As you can see, double and long double here listed as 8 byte, but in fact, some implementation long double is longer than double, and long integer is longer than integer. Okay, so this table is not complete. So sign the integer. For signed integer, we actually use this one as the table shown over here. The value increased by 1, and so it's a sign magnitude representation. And in fact, this sign magnitude implementation is called 2's complement. And 2's complement, you actually use the 2 to the power 8 minus x. For 8-bit data, use that as the negative variable. Okay. Hi, Eric. Hello. Are you there? Hello.
Come on.
Do you need me to explain what's 2's complement?
不用.
No.
No.
Are you fine with the 2's complement?
Yes.
Okay. Let me. Okay. Then in that case, let me shortly introduce the 2's complement, but I don't want to talk too long. Okay. Let me show you the 2's complement in real quick. Your positive number is like x. Say I have a 55, right? I convert it to binary. So I have a remainder 1, 2, 13, remainder 1, 2, 6, remainder 1, 2, 3, remainder 0, 2, 1, 1. So it's 3 over here. So it's 1, 1, 0, 1, 1, 1, right? That's 55, right? And now I'm going to represent my negative 55, right? So my negative 55 is actually represented as 2 to the power a minus 2 to the power a minus, let me see, okay, right here. So I'm going to represent my minus 55. So my minus 55 represented as 2 to the power a minus 55. So it actually represented as 256 minus 55. That's actually represented by 201. Okay, I'm using 201 as minus 55. That's what 2's complement is. Okay, if you have the 18-bit, 16-bit, this will use 2 to the power 16 minus x for 2 to the 2's complement. Okay, that's what 2's complement is. Okay, so I'm going to use 201. But how can I find the binary for 201? Here is the trick. Here's the trick. How can I find the 2 to the, how can I quickly find the 2's complement for 201? Here is the trick. So I have this one, 55. So I know 55. So 2 to the power a minus x equals 2 to the power 8 minus 1 minus x plus 1. Okay. So this one we call it 1's complement. Okay. And this one, 2 to the power minus 8 actually is it's the 1, 1, 1, 1, 1, 1, 1, 1. This one is this one. And then my number over here is 1, 1, 0, 1, 1, 1. So I do minus. This will give you this part. Okay, that's 1's complement. And as you can see here, you will get a result of 0, 0, 0, 1, 0, 0, 1, 1. Okay, so as you can see, if you put a 2, 0 over here, it's a bit flip. Each one is bit flip. 1's complement is bit flip. And then at the end, you plus 1. So you plus 1 here. So this one is 1, 1, 0, 0, 1, 0, 0, 1. That's 2's complement for 55. That actually is minus 55, and actually the number is 201. And that is used for 2's complement, and for the negative value for the 55. Okay, so remember that's a big flip. So remember it's a big flip. So remember it's a big flip. So -1 is like this, and then +1 is like this. Okay, so you have a big flip, right? You have big flip, so it's like 1 1 1 1 1 1 1 1 0, right? And then actually its 2's complement will be the once this one like number one you have this one 0 0 0 0 0 0 0 1, right? It's 1's complement is like big flip, right? And then +1 you will get 1 1 1 1 1 1 1 1. Okay, that actually is the 2's complement. And this one is sign magnitude. Sign magnitude is only the sign is actually sign is actually the sign bit, and the magnitude is the same. But in our system, we use the 2's complement in C language, not using this sign magnitude representation. Okay, I have to change this size. It's not actually for C++. For unsigned variable, you actually starting from 0 to 255. So there is no negative value. We call it unsigned. So unsigned, you have continuous space of 0 to 255. And sign space, you have, let me show you sign a bit 2's complement. A bit 2's complement. So A bit 2's complement, your 1 is 0 0 0 1, -1 is 1 1 1 1. This one from 0 to 127, and it negative number from -1 to -128. Okay, that's the A bit number system, binary number system. And unsigned, actually, all of the negative part are used for greater integers. So unsigned and signed actually sharing the same space. So this one actually I have an error over here. I don't want to have this same magnitude charge. So I will replace it by this A-bit number system chart over here. Okay, that makes more sense. I'll replace by this one. And as you can see, this 2's complement, it actually has any number greater than 127, greater equal to 127, actually, it will become a negative number. And on the other one, on this unsigned variable, it actually continue to grow as integer, as positive integer. Okay, so here we have the floor for 4 byte, double for 8 byte, and long double for 12 bytes. So actually this, as you can see, the long double has different definition. And in fact, some of the different installation do have different definition. And character in C, you can have unsigned character or signed character. Actually, it can have different value. So character in C actually means, that means it's a character. It actually is a byte data type in Java. So it actually is signed byte or unsigned byte. So it can represent different integer value. And if it is like character type and then unsigned character type, it actually means what? It actually means a character by the interpretation. So when you use character, you can use unsigned character. But if you assign it to character, that's also fine, as long as you don't do plus, minus, or multiplication on it. It doesn't it doesn't get interpreted as a negative value, then that's fine. But if you do want that character to be safe, you just declare the character as unsigned character type. Okay. And then this is ASCII code, your ASCII code table. Actually from using the hexadecimal system. So the left-hand side, you have the hexadecimal half byte, first half byte, and then this one has the second half byte. So for example, A is actually 41. 41 is A. And then if you want this D, it actually is 5A. Number 90, this one is a number 65 in decimal value. That's ASCII code. Let's go to the next page. So Boolean type. Boolean type, you have bool. And in order to have that bool, you need to include, if you want to use Boolean, you need to use standard bool. So there are a few good libraries you can include: standard bool, and then standard int. I remember there's also standard float. And these are 99 version, C double plus 99. They are 99 version added to C9 feature. So let's look at the, let's go to a browser. So here you have the C double plus, I'm sorry, C's standard int. So standard int.h, okay? And it's an open library, so you can use this one, check, that's the standard int.h. I give you extra integer type, like integer A underline, this T is type. A bit integer, 16 integer, bit integer, integer 32 bit, unsigned integer A bit, 16 bit, 32 bit, okay? So this one actually, if you include a standard int, give you more integer type. And then you can also do standard bool that will allow you to do using the Boolean data type. So Boolean data type is not in the core of C language. You actually need to include a standard bool h in order for you to use bool data type. And then let me see. So here is the Boolean data type. Remember to include standard bool. Let me check. Okay, I also want to check the standard float type. So this is also a standard float type. Okay, and you have a standard float type as well. So in standard float type, you also have the, let me see, CW float type. This one is 14 number, is different from standard float. The standard float is an 80 version of standard. It's an 80 libraries in 99, okay? So here I actually don't want to chase down to this topic. You will take a small time. But do remember that in 99 version, we do add different data type in. So now let's go to the first sample program, the initialization.c. So first let's go to cdev. Now it's chapter 2, initialization. I have here, let me see, C, let me see. One moment, I need to find my program. Available in so here has the initialization.c. Let me double click it. He actually had no project. So this one probably need to open by Notepad double plus. So here I have these different initial declare initialization, declare initialization, declare initialization. So when you print out, you can use the printf format. This printf format is similar to Java, and then you actually can put percentage sign D over there. So this one, printf, is similar to system.out.printf in Java language. Okay, it's similar to that in Java language. So here we have this one. So you always need to include standard io.h, and then you can have this different declaration. Now let's do this. Window R, Window command line. Right here, I have a build function. So actually right here, let me cd space, left click, copy. Yeah, and then I do build. And then actually, let me do initialization. Okay, give you the different result that you need. Okay, that's demonstration of the data type and initialization. Next one is literal. And literal is the way you represent your data from in your program. So basically, you can have a constant, and the constant actually is like 12 to 53. Now can be stored in integer type. And as I mentioned, if you want to declare it as a constant, no change constant, you just need to put the keyword const, constant, as a modifier to the variable declaration. And then you can assign 12L, that's 12 long integer type, 12U, that's unsigned integer type, UL, that actually is unsigned long integer type. So here you can also use the scientific notation, and then long flow and flow. I'm sorry, 14-point number. Okay. The next one is constant. You can have C, that's a single character, backslash N for new line, backslash T for tab, double backslash for backslash, one single backslash with double quote. That one is for double quote symbol. Backslash 06460, that actually is for octo 60. So octo 60, if you backslash 064, that means octo 60. So like 6 times 8, that give you 48. But the decimal code is 48. Okay? If you have backslash starting with leading 0, that actually is similar to what? In your Java, you have backslash, you have the 0x, that's a hexadecimal, 060, that actually leading 0 for octal, or 0p, that is 0 for binary numbers. So array of character and the string. So in string, in C language, there is no difference between array of string characters or string. In fact, there is only array of characters. In C language, there is no real string data type because it's not object-oriented. In C language, there is no string data type, but we can create string data type by using array of characters. We need to declare the size of an array that is bigger than the size of the string by 1 byte, because every string, you will have some data. And the last one, you need to put a backslash 0 over there. And backslash 0 actually means 0, 0, 0, 0. and actually it is 00. I'm sorry, it only a byte. Okay, and then you can do string initialization like this, or this. And this one is not a string. This one actually is a array of characters. And second one is a string. Third one is a string. Okay, but if you want to declare A as a string, you should do character A4, and then A, B, and then C, and then /0. That is a C string. Okay, then a constant you can also use in the macro, using the punch define. For example, you can declare a constant called debug and assign the value of 0 as a constant. And this one is different from the constant integer, because this one actually is only a macro. So it actually is replaced at the preprocessor time, not the compile time. So macro is usually used in many situations like constant, but they are not constant. They are actually a compilation directive to instruct the compiler to change the data to the debug as the 0, as a spatial data. But it actually is not a constant. It's not a variable. Debug defined by punch define, it's not a variable. It's only a macro. Macro is used to replace the number 0 for the simple debug. So debug is not variable. It's only a macro word. Be careful about that. It's used to do token replacement in the pre-processing stage. So here is the memory model. A C program has data field, uninitialized and initialized, and a text in your program. And also you have heap and stack. So let me see, if you have integer main right here, right? And before this, you declare integer A, right? And then A, actually that one is uninitialized. So put into here. If you have integer B over here, that integer will be put into stack. And then you have integer A star A equals new. Eric, any problem?
No.
Okay, right here I'm explaining where the different variable got stored. Okay, so this one, the first two are easy. Let me actually clean this up. Okay, let me go to the whiteboard. Okay, we go to the whiteboard. These three are very important. Okay, if you have the integer main program, right, and then you declare integer b, and then return something like that. Okay, and then you have integer a equals 3. Right? This one is a global variable, so you go to the data segment we call it initialized and uninitialized. So those are going to here, right? And this one is in the function, so that one go to stack, right? I go to stack. And then if you do this, if I actually not creating a array, and let's assume that's under it, okay? Not actually not existing, but under it. If you have the integer star a equals memory allocate, you allocate some memory, and then you say size of integer. You declare a a dynamic memory that actually return a pointer, and that A actually is a variable, and that A store the address to a integer in the heap over here. So that is the pointer type and dynamic data. And dynamic data, because it's a heap, so you can delete that memory location anytime. And this one in the global area, you will not be done. This one in local variable, whenever your function finish, it will be done. And dynamic memory, so this one is called static. So it's always alive. Always alive. In the data section, it's always alive. This one declared by memory allocate is can be killed. It can be killed. The one put into stack is volatile. So it's die no matter what. Okay, it will die no matter what. So let's go back to our slides. So here, if you declare a global variable, it either initialized or uninitialized. It will be stored into this section, global data section. Okay, as I mentioned, these are immortal. The data will be always there. It will never be killed. And if you use this one, integer star a equals memory allocate, okay, and then some certain memory size, those guy actually has an a as a pointer pointing to heap. Those guys are can be killed. You can kill them. And this one you cannot kill it. It's always there. Or if you under your integer main function and you declare an integer, that one go to stack, and it actually everybody will die if the function finish. Everybody will die if the function finish. So it's lifetime only in the scope of the function. And this one global is always there until the process has been killed. Or this one dynamic, it can be killed at any time you want it to. Okay, let's stop here for today. And on Thursday, I'm going to resume my chapter 2. Okay, it's 2 hours already. I don't want to check for too long. Okay, thank you. Bye now.